Have you ever wondered how it is possible to make all the lights in one city glow? Well, this can only be done by producing massive amounts of electricity. While nowadays most of the power production is conducted by non-renewable energy resources, in the future we'll have to rely on renewable ones for environmental reasons. Today we'll have a look at two renewable energy resources which could provide enough energy for us in the future. First, we'll focus on hydroelectric power. Hydroelectric power can be defined as electricity generated by turbines using the energy of moving water. There are four different ways of hydroelectric power production: conventional, pumped storage, run-of-the-river and tide. Conventional hydroelectric power production works by using the potential energy of damped water to drive a water turbine which is connected to a generator. A conventional hydroelectric power production facility consists of three parts: the reservoir, where water can be stored, the dam, which can be opened and closed to control the water flow, and the electric plant, which produces the electricity. During the power production process, water behind the dam flows through an intake and pushes against blades in a turbine, causing them to turn. The turbine then spins a generator to produce electricity. Next, we have pumped storage power production, which is used to supply high peak demands. When the demand for electricity is low, excess generation capacity is used to pump up water into a higher reservoir, and when the demand rises, power is generated by releasing the water back into the lower reservoir through turbines. The third possibility of gaining electricity with the force of the water is by using run-of-the-river power production. This type of power production is ideal for areas with no or only small reservoir capacity, but the problem is that only the water coming from upstream is available for generation, and any surplus must pass unused. Finally, we have tide power. Tide power makes use of the daily rise and fall of sea level through tides, also by channeling water through a turbine or propeller. The share of hydroelectric power on a global scale is 17%, making it the most important and widely used renewable source of energy. China is the world's largest producer of hydroelectric power, followed by Canada, Brazil, and the United States. Hydroelectric power production has many advantages, such as its minimal pollution. In addition, hydroelectric power plays a major role in reducing greenhouse gas emissions, and the water needed to run the power plant is provided free by nature. Also, hydroelectric power production has low operation and maintenance costs, and the technology used is reliable and has proven over time. Last but not least, hydroelectricity is a renewable energy source which will always be available, and the reservoirs used for power production offer recreational opportunities. However, hydroelectric power production does have a significant amount of drawbacks, such as the high investment costs, the dependence on hydrology, the risk of damaging the local fish habitat caused by fish entrainment or passage restriction, as well as a deteriorated water quality, and the biggest disadvantage of hydroelectric power production has always been the displacement of the local population. Despite its cons, hydroelectric power production is still one of the most effective methods to achieve a renewable energy future, and the market for hydroelectricity will surely grow in the future, as there are still a lot of bodies of water which are not used for power production yet. The future trend is to improve the technology, the sustainability, and to optimize the power production process of hydroelectric power plants. Now that we have taken a look at hydroelectric power, let's move on to the second energy source that we will present you today, which is wind power. Wind power is power derived from wind and used to generate electricity or mechanical power. As for hydroelectric power, wind power can also be gained in several ways. However, the main differentiation can be made between onshore and offshore wind power production. Onshore wind turbines are built into the ground, just like any other building. Most wind power plants are built in the countryside, and usually they are built in wind parks with at least 10 to 15 turbines, although sometimes only one wind turbine is used. Offshore wind turbines can either be built into the seafloor or float on the surface, with two or more anchors attached to the seafloor to prevent the wind power station from floating away. While there are different locations where wind turbines can be placed, they all work in a similar way. First, the wind direction is determined by measure instruments, and then the turbine is turned into the direction where the wind comes from. Next, the blowing wind makes the rotor of the turbine turn due to its construction. The turning rotor is connected to a generator which produces electricity. The advantages of wind power production are its low maintenance costs, the coincidence with demand for and production of electricity, as well as its high safety. Furthermore, wind power is clean since no greenhouse gases are emitted after construction, and it is cheap for a renewable energy source. Finally, wind power production has a huge potential because we could produce a lot more power than we need if we used all the wind in the world. The disadvantages of wind power include its unreliability, its optical and sound pollution, and its negative effect on wildlife. Offshore wind farms have a lot of similar advantages and disadvantages, but there are also some different ones. The advantages of offshore wind parks include higher power generation caused by stronger and steadier winds and its ability to meet the high energy demand of coastal regions. On the other side, offshore wind parks have high maintenance costs and they are difficult to build. Also, heavy storms and high waves can damage the wind turbines. Probably because of its high construction effort, wind power production only amounts for 4% of the global energy production. However, there are regional differences caused by differences in energy policies. Therefore, the share of wind power production is 11.4% of the total energy production in the EU. In Denmark, the production of wind power even makes up for 40% of its total energy production. Although wind power production plays only a minor role in global energy production right now, it is a rapidly growing market which is projected to increase by 8% in 2020. Wind power has a bright future because it is safe, clean and omnipresent. In addition to this, the prices for wind power will become even lower than they are right now, which is good news for all consumers. To conclude, we would like to tell you what the energy sources that we have presented to you are actually used for. Starting with hydroelectricity, this type of power production is only for public use because it simply does not pay off for private persons. Wind power, however, can either be used by the public, which is normally the case for big wind parks, or it can be used for private needs, where mostly one turbine produces a sufficient amount of energy. Now that we've come to the end of the video, we would like to thank you all very much for watching. We hope you could understand everything well and you enjoyed our little explainer video just as much as we did.